Alright, we'll now have a revision lecture on the induction model, the two experiments which are called the no-load test and the lock rotor test. Just like transformer, if you recall, we have the open circuit test and the short circuit test, and the objective of the open circuit test is to find RC, LV and XMLV, if you recall the parallel circuit, and the short circuit test is to find the REHV and XEHV, the series circuit. Now, likewise, for no-load test in the induction motor, we will measure the power and we will measure the voltage and we will measure the current, right? Now, the equivalent circuit of a no-load test of an induction motor is like this. No-load voltage per phase, no-load current per phase, and this is the stator resistance and the stator reactance, and this is the core loss resistance and magnetizing reactance, and this is IC and this is IM. Right? Now remember, we model our induction motor like a transformer with a primary circuit and secondary circuit. So this is the primary circuit. This is the primary circuit. So the purpose of the no-load test, is actually to find the RC and XM. Alright? The whole purpose is to find the RC and XM of the stator. Okay? Now again, you have the power no load measure, the power meters, and the voltage that you measured. And remember, it's line voltage, line voltage. And if it's a star circuit, to make it to a phase voltage, you have to divide by square root 3. And then you also have the no load current measured, which is the line current, and that is also the same as the phase current. True or not? Because it's a star connected circuit. So based on the three readings, we are supposed to find the value of RC and XM. Okay? Now how it is done? It is here. Now remember that no-load test, the power that you measured, actually consists of 3 power. Okay, the basic thing that you must remember is that it consists of 3 power. Alright? And what does it consist of? It consists of the, if you look at this diagram here, it consists of the power here. How many resistors are there? 1, right? I square R here, V square on R, parallel circuit, okay? And the rotational loss. So you must remember that no-load test, the power that I measured actually consists of 3 things. The core loss power, and the stator loss power, and the stator loss, and the core, then the rotational loss. Alright? And remember that the no-load, so therefore we are interested in RC, so we need to know the core loss power. Okay? So the core loss power is the no-load power minus the stator loss power minus the rotational loss power. Okay? Alright, we know this value. Stator loss is the I square R. Which R? RS, right? Which current? Of course, you can say line current or phase current, yeah? They are the same. The current that I mentioned is actually a line current, is also the phase current because it's star connected. And I have to multiply by 3. Why? 3 phase, right? And then minus the rotational loss. So if you are given the rotational loss value, you know RS value, you know the ammeters reading, you know the power meters reading, the core loss power can be computed. Okay? Now, then we say this is a parallel circuit, right? Parallel circuit, the best method is V square on R, because core loss is the power that we mentioned here. Core loss power is the mentioned here. So we take this as negligible. You know, this voltage is about the same as here, and we say V square on R. But this one, do you know that the core loss power must multiply by 3? Why multiply by 3? Because V square on R is only one phase, so it's 3 phase. So the voltage here is the VPH square divided by my RC, right? So core loss power I know already. Voltage I also know. Voltage is equal to my voltmeters reading, the no-load voltage, divided by square root 3, right? So that is equal to 3 multiplied by no-load voltage divided by square root 3. Yeah? And I divided by my RC. Okay, so with that, I have my voltmeters reading, I have my power, I do not know this value, so RC can be found. Okay, right. So after RC is found, then we do exactly like the Pythagoras theorem method in the transformer to go and find XM. Right? How do we do that? Right, I know RC already. I know RC already. I can find IC. If I know IC, I can find IM later. Okay? Alright, so I say IC is equal to VPH divided by RC. VPH I know because that's the voltmeters reading. I convert it to phase voltage by divided by square root 3. Right? So I know RC. So IC is known. How do I find IM? Use Pythagoras theorem method because this current is equal to IC minus GIM. Yeah? It's a right angle triangle, so I can use Pythagoras theorem method to find IM. Okay, square root of INL phase current square minus IC square. So IM is found. If IM is found, I can find XM. XM is equal to voltage divided by IM. Right? So with that, XM is found. And that is what no-load test is all about. Making use of the 3 meters reading, the wattmeters, ammeters, and voltmeters to find RC and XM. The only complication is that this is a 3-phase topic. You must know that when power is conserved, you must 3 times. Got it? Okay, let us revise it one more time. It's a method. So if you really want to tackle no-load test, you must know the method. Okay, what is it? You have a power meters reading. Okay, you measured the power that you measured is actually a 3-phase power. 3-phase power. Okay, and then you measure the voltmeter. You measure, so that is a line voltage that you are measuring. Line voltage. Okay, and you measure the line current as well, the no-load current, which is a line current. Okay, so you measure them. Then you start off the method by saying that the power that I measured is a 3-phase power that consists of 3 types of power. What are the 3 power? The one here, the one here, and the rotational loss. So it's the core loss power plus the stator loss power plus the rotational loss power. Okay, and this is the power meters reading I get. Core loss, the best formula is V square on R. So 3 times V BH square over RC. Right, so that's your core loss power. Your stator loss is 3 times I square RS. Okay, plus the rotational loss. Then check, what do I have? Do I know the phase voltage? Of course, if I know line voltage, you can find phase voltage by divided by square root 3. So I know this value. Okay, this one I do not know. Do I know the phase current? Yes, line current is the same as phase current. RS is given. Okay, so rotational loss is given. So therefore, the only unknown is RC. So RC can be found. After finding RC, you find IC. IC is Ohm's law. By using approximation, it's VPH divided by RC. Alright, then use Pythagoras theorem to find IM, which is no load phase current square minus IC square. Right? Then find XM is equal to VPH divided by IM. Right? And that is no load test. A little bit complicated, more complicated than a transformer. The complication is because it's 3-phase. Right? Remember how to find phase voltage? If you know line voltage, phase voltage is equal to line voltage divided by square root 3. How to find the phase current? It's the same as the line current because it's not connected. Alright, so that is the no load test. Thank you.